Students, I am Ankit and today we will discuss new topic, azeotropic mixture. This is our fifth video, and yesterday we discussed about the ideal and non-ideal solution. Okay, so next topic is azeotropic mixture. So student, what is azeotropic mixture? Suppose I am taking pure solvent A. Okay, so if I will heat solvent A at any temperature, then what will happen? Its vapor will be formed. Okay. So what is happening here? Composition in vapor phase is A, as well as composition in liquid phase is also A. Suppose I am taking a mixture in which two components, component A and B is there. Suppose this is sugar, or you can say salt, or any other component, and this is water. This is what? This is water. Okay, so when you will heat at high temperature, then what will you observe? Vapor of A. Vapor of A, not the vapor of B, because water is volatile than sugar. Okay, so there is a difference in the composition of liquid phase and in the vapor phase. Okay, because in liquid phase composition is A and B, but in vapor phase only A is there. It is clear? So here you can separate A from B. Suppose I am again taking another mixture in which suppose A and B is there. If I am heating this mixture at any temperature, and in vapor phase I got both A and B. A and B. So students, there is no difference in the composition. Here in vapor phase both A and B is there, as well as and in liquid phase both A and B are there. Okay, so there is no difference in the composition of vapor phase and in the liquid phase. Okay, so you cannot separate A from B, because on heating both are coming in the vapor phase. So such type of mixture which boils like a pure solvent. ये कैसे boil कर रहा है ये वाला mixture? जैसे pure solvent हो, क्योंकि pure solvent में भी liquid और vapor phase में कोई difference नहीं था. A mixture which boils like a pure solvent and there is no difference in the composition of liquid phase and in the vapor phase, this type of mixture is known as azeotropic mixture. Okay, so what is the definition? The solution of completely miscible liquid which boils at a constant temperature. Constant temperature mean इसके टेम्परेचर में कोई डिफरेंस नहीं आएगा. ठीक है, ये कंप्लीटली लगातार एक ही टेम्परेचर पे बॉयल होता रहेगा विदाउट चेंज इन देयर कॉम्पोजिशन लाइक प्योर लिक्विड. जैसे प्योर लिक्विड बॉयल होता है उसकी कॉम्पोजिशन वेपर फेज और लिक्विड फेज में सेम रहती है, उसमें कोई डिफरेंस नहीं आता है, ये उसकी तरह बिहेव करेगा. ओके, इसको बोलते हैं एज़ोट्रोपिक मिक्सचर. यू कैन ऐड मोर लाइन्स लाइक विच बॉयल्स लाइक ए प्योर सॉल्वेंट एंड देयर इज नो डिफरेंस इन द कॉम्पोजिशन ऑफ वेपर फेज एंड लिक्विड फेज. ओके, so it is of two types. First is minimum boiling azeotrope. So students, minimum boiling azeotrope are the mixture which will show positive deviation. Yesterday I told you about the positive and negative deviation. This one which will show PA is greater than XA, delta V mixing is greater than 0, delta H mixing is greater than 0, new interaction will be broken down है. और यहाँ पर मैंने लिखा था minimum boiling azeotrope. So we are talking minimum boiling azeotrope mean which will boils at low temperature than their normal boiling point. Okay, suppose I am saying boiling point of alcohol is 90 degrees Celsius. Okay, but when I will introduce cyclohexane to it, then it will boils at 80 degrees Celsius. So its boiling point has reduced. That's why it is called as minimum boiling azeotrope. और वो boiling point decrease क्यों हुआ? Because cyclohexane ने जो hydrogen bonding आ रही थी उसको तोड़ दिया था. Okay, as you are looking in the diagram. So what will happen? These are the non-ideal solution showing positive deviation from Raoult's law. Example, mixture of ethanol and cyclohexane. In this, hydrogen bonding between ethanol molecule gets dissociated by cyclohexane. Hence, solute can be easily boiled. Mixture can be easily boiled, not solute. Okay. Now come to the maximum boiling azeotrope. So what will happen? Maximum boiling azeotrope, which will show the negative deviation. And what was the negative deviation? In which everything will be less than 0. Mean Pa will be less than x into P naught A, delta V will be negative, delta H will be negative, new interaction will be formed. Okay, and example was chloroform and acetone. So again I am taking the example of chloroform and acetone. So this is acetone, this is chloroform, but after mixing they are forming a new bond. Okay, so more heat is required to break this bond, that's why it boils at higher temperature. So maximum boiling azeotrope. Okay, so these are the non-ideal solution which will show negative deviation from Raoult's law. मीन इसका मीन ये हो गया कि when the mixture of chloroform CHCl3 and acetone when you will heat chloroform then and acetone, then you will get same composition, that is chloroform and acetone in the vapor phase. Okay, so in liquid phase and vapor phase composition will be same. Okay, no difference. Mean you will not get only chloroform or only acetone in the vapor phase. You will get both chloroform and acetone in the vapor phase. Okay, so similarly in case of maximum boiling azeotrope, in vapor phase you will get both component, that is cyclohexane as well as ethanol, as well as these component will be in the liquid phase as well as in the vapor phase. Okay, so there is no difference in the composition of vapor phase and the liquid phase. Okay, so one more question is that what are azeotrope? Which boils like a pure solvent and there is no difference in the composition of vapor phase and liquid phase. Minimum boiling azeotrope. Okay, so again these are the minimum boiling azeotrope. This one. Okay, this one. Okay, minimum boiling azeotrope and maximum boiling azeotrope already we have discussed. Okay, now come to the colligative properties. Students, these are the properties which will depend on upon the number of particle and amount of solute, not on the nature of solute. Mean they will depend on the amount of solute, mass on the solute and particle of the solute and particles of the solute, not the nature of solute. Mean as you are adding sugar or you are adding NaCl, both are same for a colligative property. Mean colligative property will depend on its amount of sugar as well as on the NaCl as well as on the number of particle of sugar and number of particle of the NaCl. No, it will not depend whether you are adding sugar or NaCl. Okay, it will deal with the amount and number of particle. So these are of 4 types, students. Now rest of the chapter is based on these colligative property. First is relative lowering in vapor pressure, second elevation in boiling point, third depression in freezing point, and fourth and last is osmotic pressure. So we will discuss one by one. First is relative lowering in vapor pressure. Already student I told you that you have water, this is water molecule, and when you will heat this water molecule at any temperature, then you will get vapors of water molecule. Okay, so these vapor will exert the vapor pressure, and here I will say P naught A because it is the vapor pressure of pure solvent. Already we have discussed. Okay, but what will happen if I will add solute to it? So what will happen? This solute will cover the, suppose these are the molecules of water, but as you added solute, then this solute will cover the surface, so it will not allow the solvent molecule to go into the vapor phase on heating. Okay, what will happen on heating? Sugar molecule or solute molecule will not allow the water molecule to go into the vapor phase. So here lesser number of water molecule will come into the vapor phase. Okay, unlike in pure state में तो बहुत ज़्यादा आ गए थे because there is no hindrance, maximum molecules are coming in the vapor phase, but here lesser number of molecules are coming in the vapor phase. Here this pressure will be less and this is known as PS, that is vapor pressure of solution. So this is less and this is high. So difference P naught minus S, this is the difference. Okay, this is higher. Again I am saying it is higher, it is lower. Why it is higher? Because there is no such hindrance or crowd which will not allow the water molecule to go into the vapor phase. But here solute molecules are covering the surface, and this will not allow the water molecule to come into the vapor phase. Hence lesser number of water molecule will come into the vapor phase, and PS, that is vapor pressure of solution, will be less than that of the pure solvent. So difference, that is P naught A minus PS, is known as lowering in vapor pressure, because here is a lowering in vapor pressure. Suppose in the absence of solute its value is 500 mm. What? 500 mm. But on adding solute its value is 300 mm. So how much there is a lowering? 200. 500 minus 200, 300, that is 200 is the lowering in vapor pressure. Okay. So but if I will divide the lowering in vapor pressure by pure vapor pressure, then it is known as this whole. It is known as relative lowering in vapor pressure. What? This is known as relative lowering in vapor pressure. Okay. What? P naught minus PS, and this is what? This is lowering in vapor pressure. So students, relative lowering in vapor pressure is a colligative property, and it will depend on the what amount of solute is being added to the pure solvent. कितना solute मिलाया जा रहा है स्टूडेंट, जितना ज़्यादा solute मिलाया जाएगा उतना ही ज़्यादा सरफेस कवर हो जाएगा, और वाटर के मॉलिक्यूल को बाहर आने में बहुत ज़्यादा क्या होगी, प्रॉब्लम होगी, और उतना ही ज़्यादा प्रेशर क्या हो जाएगा, कम हो जाएगा. मीन एवरीथिंग दैट इज रिलेटिव लोवरिंग इन वेपर प्रेशर इज डिपेंडिंग अपॉन द अमाउंट ऑफ सोल्यूट एडेड. व्हाट इज XV? Amount of solute added, and here XV is the mole fraction. XV is the mole fraction. So how will you calculate mole fraction? NB upon Na plus NB. Already I told you in the first video that mole fractions are the fraction of mole of solute. Moles of solute, it is the ratio of mole of solute to the moles of solution, that is solvent plus solute. Okay. So on rearranging, look here. In place of XV, I can put NB upon Na plus NB. These are the moles of solute. These are divided by moles of solvent. Okay. For a very dilute solution in which amount of solute is very less than the amount of solvent. Okay. So in I can skip this NB, as I will compare this NB with Na. Okay. So मैं इसको क्या कर सकता हूँ, NB को छोड़ सकता हूँ, बहुत छोटा है ये Na के compare. So दिस इक्वेशन इज व्हाट? NB अपॉन Na प्लस NB. सो NB हमने स्किप कर दिया, देन वी हैव NB अपॉन Na. एंड व्हाट इज NB? मोल्स ऑफ सोल्यूट, एंड मोल्स ऑफ सोल्यूट विल बी कैलकुलेटेड बाय गिवन अमाउंट अपॉन मॉलिक्यूलर मास. सो इन प्लेस ऑफ NB आई प्लेस्ड दिस वैल्यू, एंड इन Na आई प्लेस्ड WA अपॉन MA, बट दिस इज इन ऑलरेडी इन डिनोमिनेटर. सो मैं इसको रिवर्स करके यहाँ लिख दूंगा MA अपॉन WA. ओके. सो दिस इज द फॉर्मूला for the colligative property, that is relative lowering in vapor pressure. Very important formula student, you may get one question on this topic. Okay. P naught minus PS upon P naught is equal to WB upon MB into MA upon WA. So from this formula you can calculate the molecular mass of solute. So now we will discuss some numerical. Student, read numerical number 10. At 400 degrees Celsius, okay, vapor pressure of water. So water means pure water. So P naught is equal to 55.3. Calculate the vapor pressure at same temperature over 10% aqueous solution of urea. Mean PS is equal to question mark, and 10% urea mean 10 gram of urea is present in 100 gram of solvent. Okay. So 10% mean 10 gram is urea. So what amount of solvent is there? 90 gram is left na, because solvent plus solute will be equal to 100. परसेंट तो 100 का होता है ना, ये solution है. Okay. So urea molecular mass of urea MB, you will find CONH2CO, and what is molecular mass of water? It is 18. So now we will come to its solution. Okay. So this is the solution. Question number 12. Read here, study here at this one. What was this one? Okay. So what is here? P naught is given to you 854. Okay. No, it was not the numerical. So again I need to check what was the numerical number. It was a 10. Not 10. Which one? Sorry. Student, I think we have lost the question, and it was, yes, it was 10 at 400 temperature. Now we will check the solution number 10, this one. So only direct answer is there. So how will you do? Again, I am writing the formula. P naught minus Ps upon P naught is equal to WB upon MB into MA upon WA. So students, pure water, vapor pressure of pure water is given to you. Okay, suppose it is 253, मुझे ध्यान नहीं रहा कितना था, एंड पी एस इज इक्वल टू क्वेश्चन मार्क अपॉन 253. हम मान लेते हैं 253 दे रखा है, इज इक्वल टू 10% ऑफ यूरिया सोल्यूशन वॉज देयर. सो WB वॉज 10 एंड मोलिकुलर मास ऑफ यूरिया यू विल फाइंड इट इज 60. ओके, मोलिकुलर मास ऑफ वाटर इज 18 एंड वाटर क्वांटिटी ऑफ वाटर इज 90, क्योंकि 100% सोल्यूशन था. तो यूजिंग दिस फॉर्मूला यू विल फाइंड PS. ओके, इट इज क्लियर टू ऑल. 253 वहां पर दे रखा है, आई थिंक 253 नहीं दे रखा, वो आप देख लेंगे क्या आपको दे रखा है, ठीक है ना. एंड इट इज गिवन टू यू व्हाट, this one is given to you, 55.3 is given to you. Okay, so you will do this question. So students, tomorrow we will discuss next colligative property, that is elevation in boiling point. Okay, this is very important. Okay, so thank you to understand, to listen the video. Thank you.